All right, let's jump right in. Think about this for a second. In nursing research, we're often trying to understand a massive group of people, like, say, every single diabetic patient in the entire country. Now, obviously, studying every last one of them, totally impossible. So how do researchers get answers they can actually rely on? Well, it all boils down to this really powerful technique called sampling.
And honestly, this is the best way to think about it. Sampling is exactly like tasting that one spoonful of soup. But here's the key. The goal isn't just to grab any spoonful, you need the one that tells you about the whole pot. And that's the big idea we're going to unpack right now.
This visual here, it just lays out the whole challenge perfectly. Look at that. We start with this huge, massive population. From there, research has to funnel it down to a target group, then a group they can actually reach, and finally you get this tiny little sample that gets studied. So the million-dollar question is, how on earth do we make sure that little group is a perfect mirror of the big one?
Okay, so let's get specific for a second. When we use the word population in research, we're talking about the entire group the researcher is interested in. This is our whole pot of soup, right? It's the big group we ultimately want to say something meaningful about.
And that's where sampling comes in as the practical fix. It's the method, the process of choosing that one perfect spoonful, that small subset, to represent everybody else. I mean, it's all about picking a small piece to understand the giant puzzle. And honestly, the quality of the entire study, everything, really hangs on how well you do this one thing. All right, so when a researcher decides to pick their sample, they basically come to a fork in the road. There are two main paths they can take. And believe me, the choice they make here has massive consequences for whether or not we can even trust the study's results. Okay, check this out. The difference between these two is everything. On one side, you've got probability sampling. This is all about random chance. It's like a fair lottery where every single person has a ticket. But on the other side, non-probability sampling is, well, not random. The researcher might pick people based on convenience or their own judgment. And here's why that matters so much. Probability sampling is our best weapon against bias. It lets us take what we learn from our small sample and confidently apply it to the whole population. And that, right there, is usually the entire point of quantitative research.
Now, to be fair, in nursing research, you actually see these non-probability methods a lot, mainly because they're just easier to do. You know, like convenience sampling, just grabbing whichever patients happen to be in the clinic that day. And they have their uses. But for what we're talking about today, we're going to zoom in on what's considered the gold standard for trustworthy, unbiased research.
So let's really get into the weeds with probability sampling. Why are we giving it so much attention? Simple. When the stakes are this high, we're talking about developing new ways to care for patients. We have to be absolutely confident in the research. And that confidence, it's built on a foundation of getting rid of bias. And the way you do that is through randomization.
So what's the magic rule behind all this? It's actually pretty simple, but it is incredibly powerful. Every single person in the population has to have an equal, independent, and non-zero shot at being picked. Let's break that down. Equal means nobody gets special treatment. Independent means picking you doesn't make it more or less likely that your friend gets picked. And non-zero, that just means everybody has to have a chance to be in the study in the first place. No one gets left out of the lottery.
Okay, great in theory, right? But how do researchers actually do this? Well, there are 4 key ways, 4 main techniques, and each one is designed for a different kind of situation. Let's walk through them. First up, we have the classic, simple random sampling. And yeah, it's pretty much exactly what it sounds like. This is really the most basic, a back-to-basics method. The one big catch, though, is that you need something called a sampling frame. That's just a fancy term for a complete list of every single person in the population. Once you have that list, you can just randomly pick people. Use a computer to generate random names or literally draw them from a hat. It's a great method, super pure, but the biggest hurdle is that getting that complete list, that can be almost impossible sometimes.
Okay, but what happens when your population isn't just one big similar group? What if it's made up of lots of different subgroups, and you need to make sure you hear from all of them? Well, that brings us to our second technique.
Stratified random sampling, it's a really smart way to make sure your sample isn't lopsided. What you do is you first slice up your population into these important subgroups. Researchers call them strata. So you could slice them by age, by gender, or by a specific medical diagnosis. Then you do a mini simple random sample inside each one of those slices. This is how you guarantee that your final sample is a perfect little miniature version of the real diverse population.
All right, our next method is all about dealing with reality.
Let's say your population is scattered all across the country. Trying to make one giant list of everyone? Forget about it. It's just not going to happen. So what do?
This is where cluster sampling comes to the rescue. Instead of trying to pick individual people, you randomly pick whole groups or clusters. For example, you might randomly select a bunch of hospitals from across the country. And you can even take it a step further. That's called multi-stage sampling. So first, you randomly pick the hospitals, then you randomly pick specific nursing units inside those hospitals. Now, is it as precise as the other methods? Nope, but a lot of the time, for huge studies, it's the only way that's actually possible.
And last but not least, we've got a technique that's got this nice mix of simplicity and structure.
Systematic sampling is just elegant. It's so methodical. Here's how it works. You get an ordered list of your whole population. Then you figure out your sampling interval. Let's just call it K. So if you have a list of 1,000 people and you need a sample of 100, your K is 10. Simple, right? Then you pick a random starting number between 1 and 10. Let's say you pick 7. From there, you just pick person number 7, then person 17, then 27, and you just keep going down the list, picking every 10th person until your sample is full. Pretty neat.
Okay, so we've spent a lot of time on the how of all this, but let's wrap up by coming back to the why. Why does any of this stuff matter so much, especially in a field like nursing?
Because here's the thing. Good sampling doesn't just happen by accident. It is a careful, deliberate, step-by-step process, and it's designed for one reason: to give us results we can actually believe in. Every single decision, from who your population is to which of these techniques you use, it all affects the quality of the final evidence.
And when it comes down to it, this is the whole point. This is the grand prize. The reason we go through all this trouble with these careful randomized methods is to earn the right to generalize. It's what gives us the power to take a study of, say, a few hundred patients and use it to improve the care for millions. If you don't have a representative sample, all you have are some interesting facts about a very specific small group of people. That's it.
And so that really leaves us with this one final, incredibly important question. You can have the most brilliant statistics and analysis in the world, but none of it can rescue a study that was built on a shaky, flawed sample. When your goal is to literally improve health and save lives, the evidence you're using has to be built on a rock-solid foundation. And that foundation is good sampling. The care that patients receive tomorrow truly depends on it.